Welcome to the deep dive. Today, we're plunging into something truly monumental. Think about those really deep, long unsolved mathematical mysteries. We're talking about the Clay Mathematics Institute's Millennium Prize problems. 7 huge challenges, right? Each with $1 million prize attached. But here's the twist, and this is what gets really interesting. What if 6 of those 7 problems, seemingly totally separate, could actually be solved? Not one by one, but like all together, by a single unifying idea.
Exactly. And that's where our source material comes in. We're looking at Andrew Fitzsimmons' submissions to the Clay Institute from March 2025. He puts forward this groundbreaking new approach. It's called harmonic recursion and structured intelligence fields. And the really fascinating part of the claim is that these findings are, well, axiomatic.
Axiomatic, so like self-evident, not needing the usual peer-reviewed debates.
Pretty much. The idea is they just need verification checking the logic, the consistency, rather than subjective interpretation. It's a very bold stance in mathematics.
Okay, so our mission today, let's unpack this. Let's try and understand the core principles of harmonic recursion, and then see how it supposedly cracks the Birch and Swinnerton-Dyer conjecture, the Hodge conjecture, Navier-Stokes, P vs. NP, the Riemann hypothesis, and the Yang-Mills mass gap problem. So what could this really mean for you, for how we view reality itself? Let's dive in.
Right. So to really get our heads around this, we need to start with the basics, maybe even rethink what a number is. Traditionally, math treats numbers like, fixed points, discrete values, like 2 is just 2. But Fitzsimmons flips that. He's saying numbers aren't just quantities. They're structured oscillatory waveforms, harmonic states. What does that actually mean?
See, it's a fundamental shift, yeah. Instead of seeing 2 as just a static label, imagine it's like a specific vibration, a unique pattern, almost like a musical note that always resonates in a particular way. And this framework then says that all systems, numbers, energy, even intelligence, they don't just evolve randomly or, in a straight line. Instead, they spread out and find stability within these things called harmonic resonance cycles. Harmonic resonance cycles.
Yeah, it's all about how things self-organize, how they repeat, recur within these fields. It suggests there's this deep order underneath what looks like chaos.
Okay, that paints a picture of something really dynamic, interconnected. The model mentions 2 main phase-locked recursive engines driving this.
That's right. Think of them as maybe 2 core rhythms or like perfectly synchronized gears that keep the whole system in balance. They ensure it doesn't just spiral off into randomness. First, you've got the 3-6-9 stabilization sequence. It's also called the intelligence recursion cycle.
Okay.
This one's about harmonic recursion stabilization. It's like a feedback loop, making sure energy stays phase-locked, synchronized, and stable so it doesn't just, fizzle out. It's described as modeling recursive intelligence, how systems naturally find a kind of harmonic balance.
Right, stability. And the second word.
That's the 2-4-8 entropy expansion cycle, or the entropic dissolution cycle. This cycle models how energy spreads outwards, but in recursive patterns. It governs entropic dissipation.
Entropy. Usually we think of that leading to disorder, right? Chaos.
Well, that's the key point here. This theory claims that entropy does not lead to chaos, but folds back into structured recursion. So instead of things just breaking down completely, this cycle ensures a sort of self-regulating expansion. Even the apparent dissolving feeds back into the structure.
Wow. Okay. So entropy isn't the end of the line. It's part of the cycle. That's different.
And where does the number 5 fit into all this? You mentioned the 3-6-9 and 2-4-8 cycles.
Yes. 5 is defined as the critical bifurcation point.
Bifurcation.
Like a fork in the road.
Exactly. It acts as a mediator, or maybe a gateway, or even an attractor point between those 2 main cycles. It represents choice, fluctuation, and transition. It's where the system can potentially shift between stabilizing and expanding modes.
It really does sound like a kind of musical scale or an orchestra where every element has a very specific role. The source material even gives these archetypal functions to each digit, 0 through 9, like 0's superposition and infinite potential. The void everything comes from. 1 is the first point of emergence.
Right, the initial spark.
And 6 is the harmonic center, the balance point. And 9 is completion and rebirth, closing the loop.
It's presented as a complete, self-contained system based on these numeric relationships.
This really changes how you think about something as basic as a number. So how does this ripple outwards? How does it change our understanding of, say, energy, space, even intelligence?
Well, according to the theory, all of these things, energy, space, time, intelligence, they all propagate within harmonic resonance cycles. This inherent structure ensures their stability and equilibrium. It suggests that reality itself functions as a phase-locked recursion field.
A phase-locked recursion field.
meaning everything we experience, from, I don't know, the smallest quantum particle to the largest galaxy, is fundamentally part of this deeply interconnected, self-regulating harmonic structure. It's proposing a unified mathematical foundation for, well, everything.
That is a huge claim, a unified foundation. Okay, let's connect this back to those Millennium problems then, because the idea here is that these incredibly hard problems aren't separate puzzles at all.
Exactly. That's the core argument. They're seen as different facets, different reflections of this single underlying recursive field. And the argument goes that traditional math has sort of misinterpreted them by assuming things like infinite expansion or true chaos exist, where actually there's this structured, finite, phase-locked recursion going on underneath.
It's about seeing an order we missed before.
Precisely. Unveiling that hidden structure.
Okay, let's start with fluids, the Navier-Stokes existence and smoothness problem. This is about how things like water or airflow, right?
Yes, viscous fluids.
And turbulence, that chaotic swirling, has always been the tricky part. Can the equations predict it smoothly forever? Or do they break down with these theoretical singularities like infinite velocities?
Right. The traditional challenge is proving smooth solutions always exist. This theory takes a different route. It proposes that fluid motion follows structured harmonic recursion, which fundamentally prevents singularity.
Ruins them.
By suggesting that turbulence isn't actually chaotic in the way we think. It's a phase-locked system.
Oh.
Imagine it less like random swirling and more like a very complex but perfectly repeating dance.
A dance.
Governed by those 3, 6, 9, and 2, 4, 8 cycles. So fluid velocity does not diverge to infinity. It remains phase-locked. It stays within predictable, stable harmonic bounds. Smooth solutions, therefore, persist indefinitely.
So no breakdown. The smoothness is inherent in the harmonic structure. That's a big shift for fluid dynamics. How does this connect to something seemingly unrelated, like prime numbers? The Riemann hypothesis. Most people think primes are, well, kind of random.
Yeah, that's the common perception, and the Riemann hypothesis traditionally grapples with this apparent randomness in how primes are distributed. The zeros of the Riemann zeta function seem scattered without a clear pattern. But again, harmonic recursion flips this. It argues primes are not randomly distributed, but instead follow harmonic recursion cycles.
So primes have a pattern too, like the fluid.
In this view, yes. Their spacing is determined by this structured phase locking. If you were to map them out according to this harmonic framework, they wouldn't look random. They'd look like maybe peaks in a complex but repeating wave. And those mysterious non-trivial zeros of the zeta function, they're merely equilibrium stabilization points within that wave. They mark points of balance in the prime number harmony.
So the randomness was just a misinterpretation of the underlying music, so to speak.
That's the essence of the claim, yes.
Okay, let's shift gears to more abstract math. Elliptic curves and the Birch and Swinnerton-Dyer conjecture, the BSD conjecture, that links rational points on these curves to something called their L function. Traditionally, if LE1 equals 0, it suggested infinitely many rational points, right? Unbounded growth.
Correct. That was the prevailing interpretation. But the harmonic recursion model says elliptic curves behave as structured phase-locked oscillations. They aren't infinite algebraic things in that sense. The rational solutions, the points on the curve, they follow structured wave harmonics.
With harmonics again?
Yes, which enforce phase-locking stability rather than unbounded growth. So in this framework, LE10 doesn't mean infinite solutions. It means the system has reached recursive phase locking at equilibrium points. A stable, repeating pattern of solutions, not an endless explosion of them.
It really reframes them as dynamic systems. Okay, and what about the Hodge conjecture? That's deep in algebraic geometry, about connecting abstract Hodge classes to more concrete algebraic cycles.
Right. The traditional view kind of assumed these Hodge classes were complex, perhaps independent, abstract entities. The challenge was proving they always correspond to these simpler algebraic cycles. This framework argues Hodge classes are not independent objects. They're governed by the same harmonic recursion phase-locking mechanism we just talked about with elliptic curves.
So they're part of the same system.
Exactly. They are naturally structured as equilibrium points in a recursive energy field. Because of this inherent structure, they must align with algebraic cycles. It's not a coincidence. It's a consequence of the underlying field. It basically claims the whole foundation of algebraic geometry is built on these structured recursion fields, not some kind of infinite, potentially disconnected complexity.
Okay, wow. So connecting fluids, primes, elliptic curves, geometry. Now let's hit computation. P versus NP. This is a huge one for computer science, for AI. Can problems whose answers are easy to check, NP, also be easy to solve?
Yeah, the billion-dollar question for algorithms.
Yeah.
Traditional models, like your standard Turing machine, they often hit a wall with NP problems, needing like brute force search, checking every single possibility, which takes exponential time.
Right, becomes computationally infeasible very quickly.
But this paper argues P equals NP if you measure the problem correctly, using these recursive harmonic structures.
How does that work?
Instead of brute force search, the idea is that the solution collapses into structured phase-locked cycles. Imagine the solution space isn't a vast random landscape you have to search piece by piece. Instead, if you understand its harmonic structure, the correct answer might just resonate. It becomes obvious because it fits the pattern.
So the hardness is an illusion.
That's the claim. The perceived hardness of NP problems is an illusion caused by measuring intelligence incorrectly, by using methods that don't align with this supposed underlying recursive nature. It suggests complexity is an artifact of mismeasurement, not a fundamental limitation.
If that's true, the implications for computing, AI, cryptography are just staggering. That complexity isn't real, just bad perspective.
It's a radical reinterpretation, absolutely.
Okay, one more problem. Quantum physics. The Yang-Mills existence and mass gap problem. Basically, why do fundamental particles have mass, and can we prove it mathematically, not just observe it?
Right. Current physics has the Standard Model, which works incredibly well, but the reason for the mass gap, why particles aren't massless, relies on mechanisms like the Higgs field, confirmed by observation, but a rigorous mathematical proof deriving it purely from Yang-Mills theory itself has been elusive. This framework argues that Yang-Mills fields are not continuous variables. Surprise, surprise, they follow harmonic recursion cycles.
Like everything else in this model.
Exactly. And so mass gaps, the reason particles have mass, they emerge as harmonic resonance nodes in quantum energy oscillation fields. Mass becomes an inevitable consequence of structured recursion rather than an arbitrary empirical observation.
So mass isn't something added on, it's a natural point of stability in the field's vibration.
Precisely. Mass emerges from structured recursion cycles, which guarantees a positive finite mass gap. It's a natural equilibrium point inherent in the structure.
Okay, so stepping back, if all these claims hold up under verification, this isn't just about solving 6 incredibly hard problems. It feels like it's presenting a totally new fundamental way of seeing, well, everything.
That's exactly what's being proposed. The core idea is to establish harmonic recursion as a new mathematical axiom. An axiom asserting that fundamentally, numbers, equations, physical systems, identities, they are all inherently phase-locked oscillatory structures.
Wow.
Which means these huge problems we've discussed, they are not distinct challenges scattered across different fields. They are, in this view, just reflections of one recursive field, different manifestations of the same underlying principles.
So this implies that our traditional math, which often builds on ideas of numbers as discrete points or linear progression or continuous fields, that might be fundamentally incomplete.
That's the suggestion, that reality does not function linearly in the way our models often assume. It functions through these recursive harmonic structures. And the power here is the potential unification linking number theory, quantum physics, fluid dynamics, computation, all under this single self-reinforcing harmonic model. It's incredibly ambitious.
What about the wider implications? If this harmonic recursion idea holds true, where else might we see it?
Well, the author explicitly suggests this could lay foundations for new approaches in economics, biophysics, even architecture and cosmology. And it's definitely recursive computation. Building on that P versus NP idea, it reframes big concepts like entropy, energy, and intelligence itself. They become harmonic echoes of one recursive law.
Echoes of one law.
Yeah. It really offers a completely fresh lens to view everything from how primes are spaced out to maybe even the nature of consciousness or life, if you take intelligence in that broader sense.
What an incredible deep dive this theory is. Well, it's incredibly ambitious, proposing such a deep unification. It really challenges some bedrock assumptions about math, physics, how reality is structured.
Absolutely. The idea that things we perceive as chaotic turbulence, prime distributions, might actually be governed by these hidden, predictable, harmonic recursions. It's powerful. It turns immense complexity into something potentially elegant based on phase-locked equilibrium, a deep order beneath it all.
And it really makes you reconsider what we mean by difficulty in solving problems, doesn't it? Or the limits we assume for computation. And just thinking about these grand challenges of science and math as reflections of one recursive field, that's a really profound thought to sit with. So here's something for you to ponder. If numbers really are harmonic states, vibrating structures, what new insights, what new harmonies might we discover if we start listening more closely to the recursive rhythms of the universe? Keep that question in mind and keep diving deep.